This week in Math 278, we're still working in the 7th grade. This time we're working on geometry. There are a lot of different components, even though the standards don't look like a lot. There's a lot of different things happening within them. Supplementary, complementary, adjacent, and vertical angles form important relationships. We can find angle measures with equations that show the relationships between these angles. So let's assume that the MP is perpendicular to QP. Find the value of X. Well, right away, I see that these two that are across from each other, these are vertical angles, so these are equal to each other. I also know that these two adjacent angles to one another need to add up to 90 degrees based on the 90-degree angle over here. So if these two are equivalent, and I know that these two add up to 90 degrees, I can say that 60 minus x plus 2x minus 5 is equal to 90. I then can simplify my parentheses. We can combine like terms since negative 1x plus 2x is 1x, and 60 minus 5 is 55. I need to subtract 55 from both sides, so x is equal to 35. Find the value of x and y. We'll assume that CA and BE are perpendicular to one another. I see that angle X is a vertical angle to angle DAE here. Further, I know that it is adjacent, and these two together must be 90 degrees. Therefore, x plus 74 is 90. I subtract 74 from both sides. We get x is equal to 16. I also know that angle 16 here plus y, all of this, because these two are adjacent together and they form the line BE, must equal 180 degrees. So to find y, we subtract 16 from both sides. So y is equal to 164. Determine how many triangles can be formed given triangle ABC with length AB of 6 2/10 centimeters, BC is 3 1/10 centimeter, and angle A is equal to 14 degrees. So I'm going to lay down a line AB and measure out 6.2 centimeters. Then I will create angle A using 14 degrees with my protractor. Connecting where they should to create 3.1 centimeters off of angle B, that will be angles, that will hit the vertex angle C. Now imagine me shifting this 3.1 over this direction here. So we just kind of shifted it. It will hit our dotted line of the 14 degrees one more time, which means that I can form two different triangles based on those measurements. Determine how many triangles will be formed given the side lengths 2.5 centimeters, 3.4 centimeters, and 6.0 centimeters. So I have the different triangles laid out here. And just hold on real quick here. I'm going to show you some things, and then we're going to talk about it. So if I were to add together the purple and the blue and the green, we would get 8.5. So 8.5 is greater than the other length, 3.4, so that's okay. If I were to add the purple and the blue together, we would get 9.4, which is greater than the third length of 2.5. That's okay as well. However, if I were to add 3.4 and 2.5, we get 5.9. That is not greater than the other length, so this is not okay. Because the sum of two lengths of the triangle is not greater than the third side for all three different sets, no triangle will form. Determine if a unique triangle, more than one triangle, or no triangle will form given the following attributes: 30 degrees, 60 degrees, and 90 degrees. A triangle has a total of 180 degrees. So 30 plus 60 plus 90 is 180 degrees. Further, there could be many different lengths of sides that make up these triangles with those degrees. Therefore, more than one triangle can be formed. Scale drawings may be smaller, larger, or the same size as the original. Find the scale dimensions given the original figure and a scale factor of 3. So our original figure is 4 millimeters by 2 millimeters. If I want to scale this by 3, 4 times 3 is 12, and 2 times 3 is 6. So the new size must be a 6 millimeter by 12 millimeter. Notice that my side grew by 2, 4, 6, and this side grew by 4, 8, 12. Find the scale dimensions given the original figure and a scale factor of 3/4. We're starting with an 8 by 12. So 3/4 of 8 is 6, and 3/4 of 12 is 9. So our new rectangle must be a 6 by 9. It is 3/4 the size of the original rectangle. To find the dimensions of a scale figure by multiplying the original dimensions by the scale factor. A scale factor of 4 was used to create this rectangle below. What are the dimensions of the... So we ask ourselves, what times 4 would give us 3, and what times 4 would give us 5? We do not know the original dimensions yet. So we can replace the question mark with a variable. So 4x equals 3. When we divide each side by 4, x is equal to 3/4. On the bottom side here, 4x equals 5. Divide by 4, so x equals 5/4. The dimensions of the original rectangle is 3/4 inches by 5/4 of an inch. Perimeters of scale figures are proportional to the perimeters of the original figures. Find the perimeter of the scale drawn given the perimeter of the original and the scale factor. So we have the perimeter of 38 centimeters, and we're giving this a scale factor of 2. So 2 times the side length of 10 would be 20, and 2 times the side length of 9 would be 18. So 2 times the perimeter of 38 would have to be 76. And if I were to add 20 plus 20 plus 18 plus 18, we would get 76. 76. Find the perimeter of the scale drawing given the perimeter of the original and the scale factor. So the original perimeter is 45 and the scale factor is 3. We know that we can take the perimeter and multiply by the factor to get the scale perimeter of our new one for 135 centimeters. Find the perimeter of the original figure given the perimeter of the scale drawing and the scale factor. So this is now scaled. We want to know what the original one is. So instead of multiplying, we will divide. 9 divided by 3 is 3 for one of our sides. The second side would be 6 divided by 3, so 2. And then the perimeter, 30 divided by 3, would be 10. Find the perimeter of the original figure given the perimeter of the scale drawing and the scale factor. So our perimeter of our scale drawing is 10. We want to know the original, so we need to divide by the scale factor of 5. So our perimeter is 2. Areas of pairs of scaled figures are related by the square of the scale factor. Given a scale factor of 3 and the image below, find the area of the scaled figure. So the area of our scaled figure will be as follows. Notice that our original figure had 3 across. So we need to take this 3 across and multiply it by 3. So it's now 9 across. Further, it is 1 down multiplied by 3. So 1, 2, 3. This is 27 square units. So the area of our original is a 1 by 3 multiplied by the square scale of 3 squared. So the scale factor squared times the original area. Given a scale factor of 1/2 and the image, find the area of the scaled figure. So the area of the original figure is 8 times 4, so 32. The scaled area then is the scale squared, so 1/2 squared times the area of 32. 1/2 squared is 1/4, and 1/4 of 32 is 8. We can verify this by taking the scale of the side length of 4 as 2, and half the side length of 8 is 4. Charlie says since everything on an elementary field is scaled by a factor of 2/3, it means the following. You need to hit the ball 2/3 the distance to get a home run. You need to run 2/3 the distance to run around the bases, and there is 2/3 as much grass in the infield. Do you agree with him? Why or why not? I have pictured their professional field. We know that the dimensions and area of a scale drawing relate to the original dimensions and area by the scale factor and the square of the scale factor. So the area of a pro field, since it is a square, is 90 times 90, so 8,100. The distance around the bases is 4 times 90. Since from home plate to first is 90, first to second is 90. Oh, that must be home plate. Home plate to first is 90, first to second is 90, second to third is 90, and third to home is 90. So a distance is 360 feet all around the bases. So let's find the area multiplied by the scale factor. So the total area of the pro field is 8,000 times the scale factor of 2/3 squared. That gives us 8,100 times 4/9, which is equivalent to 3,600. The distance around the bases multiplied by the scale factor. Since we know perimeter, we just need to multiply, but not by the square. Just multiply by the factor. So 360 times 2/3 is 240. The dimensions multiplied by a scale factor. So 90 times 2/3 is 60. So one length is 60. Then 60 times 60, since that is the scaled portion, is 3,600, and 60 times 4 is 240. So Charlie is correct.